In a strategic first strike scenario, an adversary launches a long-range nuclear missile toward an Indian population center. It tears through the cloud layer, rapidly gaining altitude as it heads for the upper atmosphere. If a defensive system intercepts that warhead directly over the target, the city might avoid the heat and pressure of the blast. However, destroying a nuclear weapon in the lower atmosphere releases radioactive fallout, fine particles that wind currents carry across the country. These missiles follow a high arcing path, leaving the atmosphere entirely to travel through the void of space. They re-enter at speeds exceeding Mach 20. Standard air defenses cannot handle these velocities, leaving commanders only seconds to react before impact. This creates a challenge for India's no first-use nuclear doctrine. Because the country pledges not to strike first, the strategy relies entirely on surviving and neutralizing an incoming attack before it reaches its target. Preventing a nuclear catastrophe requires more than just stopping the missile. It requires a system that can engage the threat in deep space, thousands of kilometers away from the border. In June 2026, the DRDO completed the final development trials for its Phase II Ballistic Missile defense system. These tests put India in a select group of 5 nations, joining the US, Russia, China, and Israel, with the technology to intercept intercontinental threats. The first layer of this shield is the AD-1 interceptor. It is designed to target intermediate threats at ranges up to 3,000 kilometers, engaging them either at the very edge of the Earth's atmosphere or just inside it. By pushing the interception zone to these altitudes, the AD-1 ensures that the energy and debris of an engagement remain far enough away to prevent radioactive fallout from reaching the ground. For even longer range threats, the DRDO developed the AD-2 interceptor. This platform is specialized to track and destroy missiles originating from 5,000 to 8,000 kilometers away. The AD-2 operates almost entirely outside the atmosphere. Its goal is to strike an incoming warhead while it is still in the vacuum of space, long before it begins its high-speed descent toward the target. With Phase II, India's defensive perimeter has expanded. The nation can now attempt to neutralize threats in the exosphere long before they enter domestic airspace. Since India already operates the S-400 system, it might seem redundant to build a separate shield. However, the two systems serve very different roles. The S-400 is a multi-role platform. It is designed to defend against fighter jets, combat drones, and cruise missiles, targets that operate within the atmosphere. In contrast, the BMD system is a dedicated specialist. Its sensors and interceptors are optimized for the high-altitude trajectories and extreme speeds of ballistic missiles. This push for indigenous technology extends to the maritime domain as well. During the same testing window as the BMD trials, the DRDO validated a new capability for the Indian Navy. They conducted the maiden flight of the Naval Anti-Ship Missile, medium range. With a range of 350 kilometers, this missile can be launched from ships, helicopters, or truck-mounted launchers on land. While the S-400 and anti-ship missiles manage the atmosphere and the sea, the BMD system serves as the specialist layer guarding the orbital frontier. This technology complicates an adversary's first strike calculus. An attack that once faced no resistance now has to account for the possibility of being intercepted thousands of kilometers before reaching its target. This adds a physical layer to India's no-first-use strategy. Instead of relying solely on the threat of retaliation, the country is building a mechanism to actively counter a long-range strike. But ballistic threats are becoming more complex. New systems like maneuverable hypersonic glide vehicles and MIRVs are being developed specifically to challenge existing defense architectures. MIRV technology allows a single missile to carry multiple warheads. Once in space, these warheads separate and head toward different targets simultaneously, attempting to overwhelm a defender's sensors and interceptors. To address this, the DRDO has already started work on Phase III. This next phase focuses on developing the ADAH and ADAM interceptors, specifically intended to counter multi-warhead systems and hypersonic threats. While Phase II provides a defense against current ballistic missiles, the strategic focus is moving higher, as the edge of space becomes a critical domain for national sovereignty.